In this tutorial, we're going to be talking about the different types of cables we'll be working with out in the field. There are numerous different manufacturers of cables, but there are a lot of very similar standards across the different manufacturers, and we're going to cover just a few different points that you should know going in to do fiber optic cable splicing. Today we're going to talk about the different numbers and letters that are along the side of the cable. There is a standard of different information that you should see on the side of the cable, but as well there's also manufacturer's information that may be specific to the manufacturer themselves. So we'll start out with the first symbol here. This symbol looks like it's the old school handset of a telephone, and that is what it is to indicate that this is a telecommunications or communications cable. We would be looking for this, or you might see data. That might be another word that they would put on there. And on some very old cable, you actually see what looks like the old Ma Bell, which would have been your original rotary dial phone. That indicates the telephone symbol as well, showing that it's a telecom cable. The next section here, this happens to be the manufacturer of this cable. CommScope makes the cable. So you see the CommScope optical cable. We don't always go by this as far as understanding that we have the right cable in our hand. We do want to see that it's a telecommunications cable or a data cable for all intended purposes, unless we're on a special project. CommScope might be on a different type of cable, whether it's fiber optic or not, but optical is the most important portion that we're looking for here. The next section here, this just happens to be a delineation of information as far as the manufacturer is concerned. But these next two letters, SM, are important for what we're working with here. This stands for single mode fiber. The other type of fiber that you might see an MM. MM stands for multi-mode fiber. It's important that you identify what that is before you start working on the cable, because your splicing machine will need to be adjusted in order to be able to fuse it, and the microscopes adjust to inspect it correctly. The next couple of numbers and information that you see here is 12F, and we'll show you on some other cables that this will change regularly. And in this case, this means that the cable that I have in my hand is a 12-stranded fiber cable, 12 strands. The next series of numbers here are actually the serial information for the manufacturer as to what lot, what was manufactured. It appears as though this particular cable may have been manufactured here in 2018, but this is the serial information about the manufacturing facility. For all intended purposes, we don't need to concern ourselves with that unless we need to identify multiple cables in a bundle of cables, or the handhole has numerous suppliers of data and telecommunication in the handhole. Say in a downtown metro area, you might have as many as 12 to 15 different suppliers. Some of them may be using the same CommScope optical 12-strand single mode fiber. You would want to use this serial number to be able to identify the different cable that you need to be working with. The last number that you see here is a sequential number, as we call it in the industry. Sequential numbers generally are marked, and this information is generally marked on most cables every 2 feet. So this sequential number here is the foot marking. This means that this is within the manufacturer spool. This is the distance on this particular fiber reel that we are into the fiber, but then it also helps us to understand how far the fiber is going, if we have to shoot it for troubleshooting purposes, or if we need to be able to show the direction the fiber is running as far as counting up or counting down in identification purposes. We'll learn a lot about this when we get into some of our construction videos, but this is just an understanding of what this particular cable has inside of it. So what we've done is we've scored the cable apart here, and we broke it down. We'll show you how to break down cables in another video, but for what we're working with here, I wanted to be able to show you the makeup and construction of this particular 12-count fiber that I just showed you the outside numbering information. So as we look at this cable here, you'll see that the inside portion of this cable looks like this. But before we get to that, the construction of this cable is this is an armored cable. Armored means that on the outside we have this thick plastic covering. The thick plastic covering in most case scenarios is a rodent resistant covering. There are non-rodent resistant coverings out there. You will know them. We will have to work with them regularly. It doesn't change our process. It just means that at some point a rodent is going to try to eat through this because they just like to chew. The armor on the inside here serves multiple purposes, some to protect the actual inside of the fiber cable itself, but for the majority of the reason, it is there in order to be able to identify the cable when it's underground. They will use this to bond off for lightning strikes. If they bond this off, lightning will then pass along the bond instead of going through the cable and into the fiber itself. If it's not properly bonded each end of the cable, then generally what would happen is the lightning will strike and it'll burn through the side of the cable, burning multiple holes throughout the cable until it finds that bond point and then would exit outside of the cable. It's very important that you understand that when we get to building out the fiber cases. The next thing that's inside the cable itself is the fiber optic handcuff, we like to call it. The first portion of the fiber optic handcuff is just a simple wrap around. We don't try to pull this apart with any other tool other than the seam ripper. The seam ripper generally will go underneath here in order to be able to pull that loose. And there's two wraps around there. And that wrap, for most purposes, is just to hold on this fabric that you see here. This fabric itself is an important part of the construction of this. You'll hear us refer to cables as being icky cables or gel-filled cables, and nowadays they don't put the gel inside the fiber itself, but they only put in this fabric. This fabric, once it gets wet, it turns into the gel, and I have a piece of cable here to show you what it would look like if it was to get wet. And so as you see here, it's discolored, which usually just means that it drew some sort of water that had mud or something like that into the cable itself. But now this is now tacky and it'll stay wet or feel wet. It won't dehydrate off. It'll stay wet like this for decades. And the intention of that is that if just water was to enter the cable and it was to freeze, when it froze, it would damage the cable. It could separate the fibers apart, and it would be difficult to try to identify why the cable broke until you were able to get inside of the cable. So the one on the top here shows a fiber that had gotten wet inside, and the outside protection of the fiber reel has gelled up and in essence made the water unable to freeze. That's the only purpose for the gel within a gel-filled cable, but within this dry cable here, the purpose of that fabric is for protecting the cable. The next thing that you see when we pull back that fabric is we see more of this fiberglass. This is actually two wraps, one direction, two wraps in opposite direction, and that starts to help to build up the strength of this cable. When we look at the cable, the strength of that cable is being helped by this fiber. If we were to then take this out of the way, again, seam ripper is necessary for pulling this out. You might see some technicians use their snips to cut this. It is not recommended to use snips. The reason we wouldn't use snips in this instance is if we were to take our snips and bring them down, we would get them dangerously close to the cable, the fiber optics themselves. If we were on a live fiber cable and we cut through this, it would be detrimental to our future as fiber splicers with that particular contract. Next section that we see here is that we'll see we have one blue tube, and then we have several appearing clear or white colored tubes. In this particular case, we have a 12-strand fiber. 12-strand fiber generally means it's going to be one buffer tube. That would be this blue tube. In the color coding of things, blue is usually the first tube, then we would have an orange tube, we'd have a green tube, we'd have a brown tube, slate, white, in order until we run out of colors, which I don't think we can run out of colors at this point. But these filler tubes are just to be able to fill out the full portion of the cable, to be able to make something that is structurally sound. The final thing within the cable itself that we have as far as the construction is concerned, this piece here, it's broke just from our preparation purposes of things, but it's called the strength member. The strength member can range in size from as small as what this one is here on up to nearly to approximately 1/4 of an inch or up to 3/8 of an inch in diameter, depending on the size of the cable. It's necessary. That becomes the, as they call it, strength member. It keeps the fiber from bending easily. In this way, it also helps when you support this fiber and you have to pull it, it becomes the portion that keeps its strength as you pull the fiber. If we were to pull this cable apart further, you'd be able to see that this is wrapped in one direction, but then it stops every 2 feet and wraps the opposite direction. That's intended, it's intentional on the cable itself for the purposes of stretch. If we were to pull the cable out, it allows it to stretch further without damaging the cable. Because it just in essence just unwraps. But as well, if we have to do mid-span entries on these cables, meaning it's a complete cable and we have to go into the middle of the fiber, which you'll learn about in subsequent videos, this gives you the ability to be able to unwrap this fiber from around the strength member, plus the other fiber tubes, buffer tubes that would be inside the cable, giving you access to be able to work on a single buffer tube within that. One thing that I overlooked in our conversation here was these rip cords. We don't always have a rip cord within the fibers, cables themselves. Nowadays, generally there'll be 2, and the purposes of that are to be able to create what you see here. We would expose the end of this fiber, we would have these 2 rip cords inside the cable, and then you would start the rip cord on one side, ripping it down, start the rip cord on the opposite side, rip it down, and then that opens the cable up for us to be able to work on it instead of having to try to manually take this apart. Looking at some other types of fiber just to have an understanding. If I was to pull up this fiber here, the numbers on this would tell me that this is a 72 strand fiber. I should have a reasonable expectation that when I open this up, it looks very much like the 12 strand fiber that we just looked at. And as you can see that we've already prepped this one to see that, again, it has the plastic shield, has the armor on the inside, and then we see several other pieces here. These again are just part of the strength aspect of this. This allows to add more rigidity and pull capabilities to the outside of the cable so that the sheath and this work together in symmetry. Then of course inside the cable, when we get a little bit further in, as we start to pull this apart, let me grab a set of snips to be able to do that. Actually, I'll just grab this tool. We'll break this apart here. If you notice as I'm doing this, which you'll learn in later videos, we always work away from the fiber so that we don't slice through a buffer tube. Nothing's going to slow you down more than if you have to re-prep an entire case, or if you happen to be working on a mid-span entry and you cut through a fiber tube. That's a hurry up and get the job done so that you can get the customers that you just cut offline back up online. Incidentally, that we're not expecting to be offline. So as you can see, I'm exposing this cable here. In a 72 count cable, if we have 12 buffer tubes per cable, we can expect that within this, that I would see numerous buffer tubes to the tune of about 6 of them. So if that's the case, what you just saw fall off there was where when we prepped this, we broke this loose. Normally all of this is all going to be cut off. And as I mentioned before, we can spin this out. Now you will notice that on this fiber cable here, there are no filler tubes to fill in the space between the different buffer tubes. But as we talked about earlier, if we were to look at this cable, we have a blue, an orange, a green, a brown, a slate, a white. That means that we have 72 fibers within this. So 6 different buffer tubes, 12 per buffer tube. Now, 12 is a standard within the industry, but it is not always the case. You may have 6 fibers in a buffer tube. Some situations, they may have 6 in most of the buffer tubes. In some older fiber that's been constructed out there, we'll end up having, at some point, you'll see some that'll have 6 in all the buffer tubes, except for the last buffer tube will have just 4 fibers in it. What I'm doing now is I'm just going to show you that if I opened up this cable using my scoring tool here, I'm going to spin it around, snap it loose, pull this loose. In this particular cable, again, we talked about this as a dry cable, so it's not a gel-filled cable. As you'll see, there's nothing on that. It's just the fibers themselves. And if I pull these fibers out and I shake them, you'll see that there's actually more than 12 particular strands inside here. 2 of the strands, this happens to be the 2 strands in my fingers here that we'll zoom in on a different shot. But these two strands that I have in my fingers right now, these are actually strands that are designed very much like this fabric that we saw on the outside of the cable. When they get wet, they then turn into a gel that will not allow the water to freeze inside the buffer tube itself. Again, if water was to enter into the buffer tube for any reason whatsoever, we've seen many cases filled with water. We've actually had to de-thaw the inside of a case that had frozen completely solid inside. Well, if the water is inside the case, then there's the high likelihood that the water can then wick inside of here due to the temperatures heating and cooling. It'll eventually draw into this like a straw. If that has the ability to be able to freeze inside of there, it has the potential to snap the fibers in two. Again, if we were looking at inspection purposes and whatnot, if that had froze and it froze those fibers and broke those fibers, it would take us a long time to find that problem. So once this two strands, they get wet, they turn to a gel, it'll no longer has the capability to be able to freeze. One last fiber that I want to be able to show you is a rather massive fiber here. We're not talking about ribbon fibers just yet, but this particular cable, this is a recent project that we just worked on. It'll be some of the projects that we'll be working on over the next couple of years. If we look at this number here, you'll see that this says that it's a single mode 432 count fiber. So again, looking at this number here, then what we can expect to see inside the cable would be if we were to do 12 count fiber per strand. Instead, this happens to be or per buffer tube, excuse me, this happens to be a 24 strand per buffer tube, but this is also a gel-filled cable. Even though we see this fabric on the very outside of the cable here, once we get inside the cables, they are gel-filled. There's a reason for that on this type of cable, and that has to do with the fact that it is a yarn-coated cable, so it helps to keep the yarn in place. Those yarns are actually color-coded, and we'll go into this a little bit later on when it comes to working with yarn held together inside the buffer tube. Now this particular cable, in order to be able to fit 432 in here, you will have your standard blue, orange, green, brown, slate, white, red, black, yellow, violet, rose, aqua buffer tubes. Then you go into the dash colors, it's called, and so you'll have dash blue, dash orange, dash, and the dash in essence is that you'll see a black stripe on the side of the buffer tube like that. So in this case here, we won't break it down this cable here, but you would be using D-gel in order to be able to wipe the gel off from the cable and be able to function within it. From an efficiency standpoint, we like it when it's not gel filled. And that's it for those types of cables. There's definitely plenty of other cables out there. Once we come across them, we'll start another tutorial.